So, forging moves the world, but what moves forges is the next presentation given by Dr. Raedt. There's no need, and also in terms of time, there's no need to introduce. Can you say, please, a little bit about you, just one or two sentences, and your very young business, Prosimalis? Maybe there are some participants here, they don't know as much as I do about Prosimalis, so please introduce yourself very quickly. Thank you.
Professor Liebert, thank you very much. My name is Willi Raedt. I studied metal forming in Aachen. I did my PhD there. Between 2002 and 2020, I was with Hirschvogel in different functions, and in spring 2020, I decided to go freelance to have the engineering consultancy Prosimalis. It's about simulation, materials, and analysis, so everything I like doing. Spring 2020 was very interesting to start a new business. It was good to talk to people, but actually nothing moved. Everything was on full stop. But yeah, we survived. We're still there, and I'm very glad to finally have a face-to-face conference of being able to meet you and to get into discussion. Yeah, you will find that I have not synchronized my presentation with Eckhard Körner, but we are addressing pretty much the similar topics. Forgings move the world. What moves the forging world? Schmiedeteile bewegen die Welt. Aber was bewegt eigentlich die Schmiedewelt? Well, we'll have a look. And I would like to talk about the topic of cost, the eternal topic of cost, but obviously still relevant and probably worse even in future, if it can get worse. I want to shed some light on globalization, on process simulation, on electromobility, lightweight design, and the major part of this presentation will be about sustainability, reduction of CO2 emissions, because that's a mega trend at the moment. And the next slide. Cost. Well, the whole industry is cost-driven, especially if you supply to the automotive industry. Cost is and was and will still be the major topic that you have in discussion with your customers. What is the cost? What is the cost of a forging part? It's obviously the forging material depends on the type of process that you run. Between 30 and 70% is by forging material. Well, there used to be fixed base prices that you could rely on, maybe negotiated once a year. I put big question marks there, and the number of one fixed, they're not fixed anymore. Prices, energy is jumping up and down so strongly that the discussion about the base price is coming more often. We have scrap and other surcharges for a long time, accepted by the whole industry, only contested by the German cartel office. But this system is still alive, and we see how scrap and alloy is moving around. Nickel at the moment, for instance, scrap as well. But luckily, this is comes as a surcharge, so you don't need to negotiate every few weeks about this. And then new topic of energy surcharges. People seeing that energy is jumping around so much, why not use this the surcharge model for energy as well? In order to reduce negotiations on both sides of the forging front. All in all, if you want to reduce about forging material, buying the cheaper material is typically not the way to go, because your properties will move around, the quality of your parts will not be good. One way to go forward is to increase material efficiency. So suddenly, preforming operations might become interesting, economically interesting, which they weren't in the past. And there's a number of new developments out there, and obviously a number of established preforming operations that you can use. Labor, what used to be low-cost countries in terms of labor, they have moved around as well. Eastern Europe, eastern coast of China, the relationships are shifting. Basically, everyone will need to look to increase the productivity per capita, reduce losses, increase the quality, and automation is the way to go forward. And the next slide will address automation a little bit. Fewer losses. Well, machines are running at high production rates already in some cases, and losses means including Industry 4.0 ideas like the measuring screws from Mr. Stahlmann from Consensus, understanding the process even better, detect deviations very early during production, and to be able to react and not to find any faulty parts 3 days later in the quality department. So these are very interesting developments, together with a further detailed understanding of the process by really doing simulations, by doing robustness study with simulation, looking at the stochastics. If some parameter changes, what changes in the process, and is it still a good part or not? So I think we need to look closer, still look even closer into the processes, create a better understanding to be able to increase the quality and to reduce losses here. Energy, big topic, we just heard about it. Energy means increasing material efficiency. Whatever you don't need to buy and transport and heat up will contribute to the decrease of energy cost. So material efficiency improvements will obviously directly decrease energy cost in the forging processes. And we have a number of very nice developments in cold, warm and hot forging, new materials that need less or no heat treatment. Why are these not used? Yeah, we had projects for the last 20 years, Benedict steels, Martin synthetic steels, air hardening, no heat treatment necessary, but still the entering into the market is still taking its time. And it's really very difficult to introduce these materials, but with increasing pressure from the energy side and with increasing pressures to reduce CO2 emissions, I think this will be necessary. And yeah, if you can reduce your depreciation, that's obviously good, meaning older machines, don't buy new ones. This counter trend is automate machines, increase machine quality. Yeah, do very good maintenance. I think this is the way where the successful people go forward, not running their processes on scrap machines, but on pretty new ones and high maintenance ones, which again increases the quality of the parts and what you can do with them. Let's go to the next slide. Yeah, automation. One topic I want to concentrate a little bit on, covering the whole field of cost in forgings would take a few days, so let's focus. What I find interesting is, since I left Hirschvogel, I have the possibilities to enter some more forging companies easier than before, because that's my job now. And what I find is a wildly diverse level of automation. There's some extensively manual processes in high labor cost countries, the Black Forest, Bavaria, Switzerland, and we find highly automated processes in lower labor cost countries, the ones that used to be named best cost countries. Maybe this term is going out of the industry now. But it's pretty clear, the more flexible and the more robust automation becomes, the automation levels will go up worldwide. Labor cost is a big factor and everyone tries to reduce this. Now, let's look at some examples worldwide. Please click on the inline production in India. Inline is always good. So this is an interesting concept. 3 people working on one cold calibration process. The guy really sitting on the floor. It looks like 100 years ago, but this is a pretty recent film actually. I think he checks these conrods for thickness, and he checks if they have a hit mark or not, and if they don't, he will produce one when he chucks it on the next pile. So this is one way how you can operate. If you close this, please open the next one. Automation made in China. Maybe lots of you have seen this film already. Really great, and I don't think it's staged because they don't have any robots or transfers visible around, so I think they're really doing it like this. Unbelievable. But if the people don't cost anything and if humans are consumables as well, then you can do something like this. I'm especially worried about the large guy, the tall guy in the middle. If he sits up, he will break his neck. Okay, next film. This is a line which seems to run in China, but I got it from a LinkedIn page of an Indian guy who seems to do automation project. This is already not bad. 2 spindle presses fed by robots, fully automatic from input to output. What's interesting is, why are they going at 9 seconds per stroke? Yeah, the press is waiting for the next part, so there's still a lot of potential in this line, but it's fully automatic, running in China. It would probably cost the same to actually put people there. I don't quite know. I don't know the exact metrics of this. But we see automation efforts taking place in China, even though you would think that there's enough people there to run presses. Maybe the quality goes up, maybe the time between the processes is more constant and the properties of the parts are more constant, but yeah, I think this is the way forward. And we see this in China, and the next film will show a Chinese automation as well. I would call this solid automation. Company Jingduan, 4K film, very nice filmed. You will see every 100 parts one of these billets will actually fall over and land on the floor, so there's still room for optimization. They transport it very wide between induction and press to get some more scale maybe. But we see a transfer, we see automatic spraying within the step of the transfer. This is solid. It's not fast. It's not the highest tech that we see and that we know. But yeah, they are catching up, these guys. No time to rest in Europe, but we need to move forward, certainly. Seeing this, I mean, it's not bad. Let's look at the next slide. That's a fast automation. It's a line that was installed in China. It's not quite where the Musashi SpeedForge machine is, but it's very similar parts and very similar speed. The only thing you see is every now and then a part is missing, and this machine is able to do the pre-forging and the finish forging at the same time, so why are they leaving out parts? The question is, the induction heater is too small. It cannot give the tonnage that the press would be able to work, so basically a third of productivity lost by misplanning, I don't know, probably. But this is running in China, set up by a German machine manufacturer, so these guys are catching up. Obviously, it would be possible to show lots of more films worldwide, the Musashi SpeedForge, Hirschvogel automation. I mean, we know how hardtobos are running, when they're running, very, very fast, obviously, and there's a lot of room in between. One film I recently found I was very impressed with, a super optimized transfer, unfortunately not in forging, but in sheet metal. But this is marvelous. Look at those robots going in. This is 10 years old. I only recently found it. Obviously, the professor is ahead. But I find this really great, how they manage to have so fast robots, but only do 16 parts per minute. And the press is slowing down, doing the deep drawing in slow. I don't quite understand, because at Hirschvogel we had a cold forging, a hot forging press, a single stroke and stop press doing cold forging, millions of parts, so why not in sheet metal forming? Is that not possible? I don't know. But the robots are really great. They already start moving when the press is still coming down. That's really great stuff. And I think maybe on the robot side, the forging guys can learn something from this. Okay, let's stop this. Just a little spectrum of what's out there from 100 years old ago. You would think in current times to really highly optimized automatization. Let's go to the next slide. Yeah, cost in the automotive supply chain. What I see very often is a very warm relationship between suppliers and their customers in the automotive industry. Friend or foe, everyone says, okay, my customer is my enemy, really. The way they communicate today, it's really not good. I think some of the Asian countries are doing that better. They have cross shares in each other, so they don't need to fight so much. They can find the common optimum. And I think that the communication, especially in the European automotive industry with their suppliers, is not good. And if this kind of communication is already poisoned like this, the lack of technical communication is even worse. That costs us more money than the 1 cent that the purchasing guy can squeeze out of the customer. He wants price reduction, and price reduction, everyone will fight against it. If someone would talk really cost reduction, by understanding the product, by applying all the advantages of the process onto the component, then the cost reduction could be much higher. And cost reduction is good for both sides, because it increases competitiveness. Maybe I'm a visionary, maybe I'm a dreamer, I don't know. Maybe the whole supply chain is set up in a way that this will never work, because the purchasing guys, I think they're meant not to understand anything about the technology they're buying. That seems to be the practice, because they're exchanged every 12 to 18 months. But if the communication is lacking, then things like you see a drawing, it's full of specifications, and half of it the part actually does not need. Yeah, some components, hardness in the center, the same as everywhere else. Why? Yeah, if there's a torque on there, if there's a bending load on there, the center is so unnecessary, sometimes we drill through it and remove it. Yeah, but if it's there, why does it have to be the same hardness as the surface? It does not make any sense. That costs a lot of money. It's a complete waste what's taking place there. But if the communication is not there to make these improvements, then millions and billions of euros are just spent basically for nothing. And that would be the biggest way of saving cost in the whole process chain if a bigger, better partnership between supplier and customers would actually take place. Okay, next slide. Yeah, is burning money still part of the business? It seems so. Looking at some drawings, it certainly is. And if the understanding between product, process, and material would really increase and people would know what they're doing there, that would really be helpful. Next slide. Yeah, finding the most cost-effective solution, if you look closely and understand, it really helps. And sometimes a healthy share of boldness is maybe good as well. Try out something in the forging company and present it to your customer. Don't always talk to your controllers and lawyers. Talk to your technical guys and try out something. Maybe not like the guy behind the link. A healthy share of boldness is sometimes good. That might be a bit reckless what he's doing there. But surprisingly, he doesn't get hurt. I mean, this is not good for anything. But yeah, some boldness a healthy share of boldness might be good. Okay, next slide. Yeah, globalization, big topic, offshoring out of America into Asia, Mexico, wherever. That was a big trend in the last few years. I think currently, especially with the COVID crisis, Evergrande was already mentioned, we find that having the supply partners somewhere else in the world, 10,000 kilometers away, might not always be the best move. Now some other factors become really visible. If controllers only look at the purchasing cost center, reducing prices every year is good. If they don't take into account the last-minute business flights to some central part of China to find a problem and to resolve it, if they don't take into account the logistic costs of flying stuff around the world because it doesn't arrive on ship in time, then I think the picture actually changed. So what used to be best cost countries, if you really look at the complete pictures, are not best cost countries, and I'm pretty sure they haven't been for the last year. So logistic costs, costs of suspended or broken supply chains, communication and problem fixing costs, and simply costs from resulting a lack of communication, from technical communication on a development level, where you can really reduce the cost of the product. Not only the price, but the cost. That is good. And what we see, April 28, thousands of ships waiting to be loaded and unloaded in Shanghai just depicts what's happening at the moment. The supply chains are broken, the semiconductors are not coming, and the car makers are selling less cars than they could at an overall high corporate profit. So maybe that will be the strategy of the future. Who knows, but I'm sure the Koreans or the Japanese will kick in and deliver the small and medium-sized cars in future, and then we don't do that in Germany. Okay, if that's the strategy, let's see what happens. Next slide. Actually, simulation was on my agenda as well, but I will talk about that tomorrow. So we'll leave it out today. Electrification, a big topic. This seems to be the mega trend at the moment. Fuel cells, synthetics, hybrids are out anyway. So the market and the business will be changing. I personally think there will be a saturation point for electric vehicles. But let's see, in the end, the customer will decide, and not politics and not some green table strategy. What was evaluated by a study of the German Forging Association is that full electrification will lead to a 20% reduction in forgings in automotive applications. But what's the upside? There's new components coming along with electromobility, rotor shafts, the electrical transmission, the reducer transmission like we see on the right-hand side, the electric transmissions for the dedicated hybrid, which might be a better way to go forward with hybrid. In battery cases, there are some new parts. The demands on crash will actually go up continuously, and there is a place for forgings in the body of the car. Especially where high crash is related and the high energy consumption of forgings, high stresses, high flow stresses and high ductility, forgings will play a role in future there. And there are some product families, they will just simply remain untouched, so it makes sense to concentrate on those. Okay, it's obviously very important to stay alert. If you go next, there will be a link. Please do the right, yes, thank you, right arrow. So stay awake, example 1. company Gosho, our friends at Gosho near Osaka in Japan, they make a rotor shaft by a single-stage cold forging process. This is a typical Toyota-type rotor shaft with this kind of bevel geometry on the outside. And this is especially fascinating if we look inside. We see the keyway on both sides forged, so very unsymmetrical cold forging that they've done there. And it's hollow on both sides, that fellow. We see the crosscut in a second. A very long backward extrusion and forward extrusion taking place there. And both sides hollow, so very high tool loads. I don't know if it's a prototype or if running in serious production, but I think this is a nice piece of cold forging. Let's look at the next film. There's another one coming. If you go, yes, thank you. Again, electromobility. This is an intermediate gear or an input gear of the differential, which will be in electrical transmission as well. And what are they doing there? They're forging the helical gear on the outside along a big topic of research in Germany, but I don't think in Germany anyone is doing this in serious production. What they managed to do is eject very, very fast. And this will be the key for making these components. Eject fast. If it sits in the die too long, the expensive die will just will only survive for 5 parts. Again, I don't know if it's a prototype or really in serious production, who knows, but if you don't try out, you will never get in this way. They're saving material, they're saving CO2, so it's all going in the right direction, and these parts will be needed in electrical transmission of the future as well. Okay, enough for this film. Let's go for the next slide. Lightweight design, yeah, thank you, Eckhard, for showing the picture. I think this was a great project in forging industry, and we demonstrated that we can contribute to lightweight forging with steel forgings and with forging technology very much. Okay, and what's the next big topic on the agenda? Next slide. It's CO2 emissions, it's CO2 reductions, and for this, again, thank you for mentioning before, we have started the project No Carb Forging 2050 in the German Forging Association. Next slide. Yeah, what's the way to go? It's not a dead end. We need to keep moving forward, and I'm pretty sure that technical developments will be able to reduce the climate effect or deal with the effects that are coming for hotter climate. So no need to panic. But we need to do something. Not doing anything is not an option anymore. Or BMW guy said, the cost of doing nothing is more than the cost of doing something. So we need to do something. Next slide. We see customers, we see politics, we see financing, banks saying, hey, forging companies, you need to do something. Next slide. And this is Scheffler writing a letter to suppliers, give us your offer only with CO2 footprint, and explain to us what are you going to do the next years to reduce CO2 emissions. Next slide. So German Forging Association said, let's start a project, and 52 companies said, hey, we want to be part of it. We all have the same problem. Let's share the efforts in dealing with the topic of CO2. Next slide. There were some partners, including Prosimalis, helping in this project. Next slide. And what we did first was create a product carbon footprint calculation tool, because none of the data available was granular enough to find out what are the factors on the CO2 emissions and where to start first in order to reduce it. Next slide. Next slide. So we've created a product carbon footprint calculator, and you see a screenshot on the right-hand side of this where we can flexibly put the process chains together. We have industrial data going into the calculation, and we're able to really design and redesign process chains and calculate CO2 emissions and where to reduce first with obviously least cost impact. Okay, next slide. We could look at Fred live. We don't have the time, and I don't have the keyboard in front of me, but please, if you're interested, let's come together later and we can have a live look in Fred how it works. And if you're interested, IMO is now opening Fred to other people interested, so please contact me, please contact Mr. Hein from Forging Association if you're interested in having a look in Fred or maybe using it for your purposes to be able to answer the customers. And the next step is coming together, which we did on 11th of November last year, a kind of 2-week time slot when it was possible to meet, and we just sweetly hit that. and we collected ideas and we put them into FRED. And next slide, if you take some of the actions that are already available on the market into account, like a fork, a yoke from a powertrain, you can reduce it from 720 grams of CO2 emissions to 196 with stuff which is available. It's not rocket science. Going to zero is another story, but reducing it by 60% is already a good start, I think. Okay, next slide. There should have been one conclusion. Anyway, conclusion is look forward, don't panic, do the right stuff. We will survive and we'll do better in a partnership which is represented in this room today and with some friends outside on screens. Thank you very much.
Dear Mr. Raedt, thank you very much. It was really a firework, just in time. Thank you very much.